Hello everyone, in this video we are going to talk about continuity of a function. This is the given function and some data is given. Okay, so for x in rational numbers the function is x square, and for x which is not rational the function is 5x minus 6. Okay, so basically when x is rational the function is x square, and when x is irrational, x does not belong to Q means x is irrational, then the function is 5x minus 6, and you have to check for continuity of this function. Okay, continuity of f. Okay, so the question mark, so the basically where the function is continuous, or even at all if it is continuous, you have to check. Okay, so anyway, there is also a quick trick to solve these kind of problems. Okay, once you just look at these expressions, you can actually say where the function is continuous. Okay, we'll also learn the trick, and that is the content of this video. So if you're liking the content, kindly take a moment to like this video, and of course subscribe our channel to learn more and more high quality mathematics. Anyway, so let us start with the problem. The given function is f, right? And it has two expressions, x square and 5x minus 6. So let us try to draw this graph. Okay, graph of this function. So somewhere it is 0, right? And fx equal to x square for x when x is rational. So basically it will be like, I'll draw dotted lines because it is only for rationals, not for irrationals, right? For irrationals. Okay, and for irrationals you get 5x minus 6. Again it is a dotted line, and 5x minus 6 will be like so at x equal to 0 it is minus 6, so at x equal to 0 somewhere minus 6 somewhere here. Okay, and 5x minus 6, so basically y equal to, or fx equal to 5x minus 6, which is a straight line, right? So then the question is whether this straight line will cut this, so this is actually x square. Okay, and I can draw 5x minus 6 somewhere, right? 5x minus 6, it should go through the point. Okay, so this is minus 6, the height is minus 6 because at x equal to 0 the functional value is minus 6. Anyway, the question is whether this line will intersect this. This is again a dotted line, but okay, I have drawn this way. Whether this line will intersect this, that's the important question here. Okay, for that, how can we decide whether y equal to x square and y equal to 5x minus 6? So basically we have to check two things. Y or equal to fx you can write, because fx is given here. So fx equal to x square and fx equal to 5x minus 6, right? So whether they intersect, these two curves intersect. Okay, how to decide? We can just actually equate them. X square equal to 5x minus 6. If this has solution, okay, if this has solution, if this has solution, then they will intersect particularly in those points. Okay, so let us try to solve this. If it is solvable, let us try to find whether there are solutions. So it becomes x square minus 5x minus plus 6 equal to 0, right? You can just try to factor it out. So you will get x plus x minus 3, sorry, x minus 3 into x minus 2 equal to 0, right? So therefore there are two solutions, x equal to 2 and x equal to 3. So solutions means what? Solution means at x equal to 2, somewhere at x equal to 2 and x equal to 3, this function, this line y equal to 5x minus 6 will actually cut this graph y equal to x square, because at those points the y values are same. The y values means x square equal to 5x minus 6, right? So this line will actually intersect this y equal to x square graph. Let us erase this then. This is of no point because the graphs are actually intersecting. Okay, I will also show using Desmos how these two things actually occur. So here we will actually calculate the graphs. Actually, this is the graph calculator, online graph calculator called Desmos. Okay, here we will draw the graphs x square. So this is like this. Let me just here. Okay, and then if you write 5x minus 6, 5x minus 6, then you see this is the graph. Okay, and this is why by hand it is very difficult to calculate to actually draw these graphs, because do you see the intersection points here? So here is one intersection and here is another intersection, and this is at x equal to 3. The latter one is at x equal to 3. This is x equal to 3. Okay, and this is x equal to 2. You see at x equal to 2 also there is an intersection, and there is no other, there will not be any other intersection, because we have solved the equations and found only x equal to 2 and 3, right? And so this is almost tangential, but okay, there are two intersections, right? And yeah, so at these two intersections the function will be continuous, otherwise the function will not be continuous because their values are much different from each other. Okay, so that's the beauty, and actually it is difficult to draw by hand because it is so tangential. Okay, yeah, so this is the explanation using the graph. Okay, yeah, so now we are going back to our notes. So if these are the intersection point, the trick is this: the function f is continuous only at x equal to 2 and x equal to 3. Okay, so wherever those values are actually equal, then the function is continuous at those particular points. Okay, so at x equal to 2, x equal to 3, these values are same, x square equal to 5x minus 6, and therefore these are the only points where this function is continuous. In general, if it is given like this, so x belongs to rational something, x belongs to irrational something, you have to draw the graphs. If there is intersection, then only at that point or those points the function will be continuous, otherwise the function will not be continuous. Why? Because if you just look at the intersection point, so let's draw this somehow here. Okay, suppose some intersection point here. Okay, so via you go this functional values or these functional values. Okay, the limit they are going to be the same. Okay, so you take it irrational or rational sequence here on the line, or irrational sequence, or a mixture of them, it doesn't matter. So basically if you choose any sequence here xn which is converging to suppose 2 here, okay, then fxn must converge, so let me write this way, must converge to f2, which is this, right? Okay, so that's the theory actually, and this is the explanation. So because if xn you take either irrational or rational, right? But for any for any of those, the functional values are approaching this point, right? This height when xn is approaching 2. So suppose this is 2. Okay, so when xn is approaching 2, or anything, if you take any sequence which is approaching 2, then f of that will also approach f2 actually, f2, and that is why the function f is continuous at x equal to 2. Similarly, at x equal to 3 also the function is continuous. And similarly, if they have, suppose it is x cube and this is something else, some other expression, you just have to solve them, you find the common points, and then at those points the function is continuous. Otherwise, which means outside those points the function is not continuous. Okay, that's all in this video, and I thank you for watching.